Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 9 students and the topic of discussion is polynomials. This is the second video on this topic. In the previous video we introduced you to the topic of polynomials where we discussed value of polynomial, degree of a polynomial and the factor theorem. In this video we will be focusing on the problem solving approach. Let's begin with. Here in this problem we have to find degree of the polynomial p of x equal to 2x cube plus 4x square minus x minus 7 power 5. We have discussed in the first video on polynomials the degree of the variable is the highest power of the variable. So the variable here is x and the highest power here is x cube. So 3 is the degree of the polynomial. Please note that this minus 7 power 5 is not the degree, this is a constant term. So many students do a mistake, they may write 5 as the degree of polynomial, which is incorrect. We have to see the variable, its highest power. So the degree is 3. Now let us give few examples of linear, quadratic and cubic polynomial. So p of y equal to minus y plus 3 is a linear polynomial. Why it is a linear? Because y has a power 1 only. If y has a power 1 or the variable has a power 1, it is a linear polynomial. Consider another case, p of z equal to 4z square minus z. It is a quadratic polynomial because it has a degree 2. The variable z has a power 2. So it is a quadratic polynomial. Similarly, consider another polynomial p of t equal to t cube minus 5t plus root 7. This is a cubic polynomial because the variable t has a degree 3. Find value of the polynomial at x equal to 2. This is the polynomial given p of x equal to minus 4x square plus 5x plus 3. So we substitute x equal to 2 in this equation. So we write it as p of x equal to 2 equal to minus 4. X square is written as 2 square plus 5 into 2 plus 3. So 2 square is 4. 4 into 4 is minus 16. 5 into 2 is plus 10. Plus 3 is the remaining term. So 10 plus 3 13 minus 16 is minus 3. So the value of polynomial at x equal to 2 is minus 3. Now in the next problem we have to verify that 1 is the 0 of the polynomial. This is the polynomial p of x equal to x square minus x. We have to verify that 1 is the 0 of this polynomial. So how do we verify? We substitute this 1 into this, and if p of x is becoming 0, then it is the 0 of the polynomial. So we substitute 1 as in place of x. So p of x equal to 1 square minus 1. 1 square is 1. 1 minus 1 is 0. So the polynomial is turning to 0 when we substitute 1. So 1 is the 0 of the polynomial. So it is proved. Check whether x plus 1 is a factor of the polynomial x cube plus x square plus x plus 1. Is the problem? Now recollect that by factor theorem, we have seen earlier that if x minus a is a factor of a polynomial, then a is the one of its zeros. Similarly, if x plus 1 is a factor, this we have to check it, is a factor of this polynomial, then x equal to minus 1 is one of its zeros. We can equate this as 0 equal to 0, so we will get x equal to minus 1 is one of its zeros. So let us put minus 1 in this to see whether this polynomial becomes 0. P of x equal to minus 1 equal to minus 1 cube plus minus 1 square minus 1 plus 1. So minus 1 cube is minus 1, minus 1 square is plus 1, and the remaining minus 1 plus 1. Minus 1 plus 1 is 0, minus 1 plus 1 is 0. So p of x equal to minus 1 is 0. So minus 1 is indeed the 0 of this polynomial. If minus 1 is the 0, then x plus 1 is the factor of the polynomial. For argument's sake, if this term was not becoming 0, then x equal to minus 1 will not be the 0 of the polynomial and x plus 1 will not be a factor in that case. But in the present problem, x plus 1 is the factor we have seen. Find the value of k if x minus 1 is a factor of 2x square plus kx plus root 2. We need to determine the value of k. So if x minus 1 is a factor, by factor theorem, if x minus 1 is a factor, then its 0 is 1. How? We equate this x minus 1 equal to 0. So x will be 1. So x equal to 1 is one of its zeros. If one of its 0 is 1, then p of x, when we put x equal to 1, this expression should become 0. So we write this as p of x equal to 1, 2 into 1 square plus k into 1 plus root 2 equal to 0. Because x equal to 1 is one of its 0. Zero's definition is when we substitute the 0, the whole expression should become 0. So here k will remain here, root 2 will go on the right side, 2 into 1 square is 2. So minus 2 and minus root 2. K will be minus 2 minus root 2 since they go on the RHS. So this is the value of k. Now factorize 3x square minus x minus 4. For a quadratic equation, we can use the splitting method. So how do we split? We have to split minus 1x such that the product is 3 into minus 4, which is minus 12. So we have to split minus 1, which is the coefficient of x, such that its product is 3 into minus 4, which is minus 12. So how do we split 3 and minus 4? 3 into minus 4 is minus 12 and 3 minus 4 is minus x. So we write this minus x as 3x minus 4x and the other terms are kept as it is. So this becomes 3x square plus 3x minus 4x minus 4. In this 3x can be taken as common first two terms. So 3x and remaining will be x plus 1. Let us check it. 3x into x is 3x square. 3x into 1 is 3x. Similarly here minus 4 will be common. Minus 4 is taken common. Again x plus 1 will come. Now x plus 1 is taken as common and the balance term will be 3x minus 4. So the factorization of this expression is 3x minus 4 into x plus 1. Now in this problem we have to factorize a cubic polynomial because this is a cubic polynomial because it has a degree 3. Factorize x cube minus 3x square minus 9x minus 5. Whenever you have a cubic polynomial, you need to find one of its 0 first. That should be our aim. So how do we proceed that? How do we find 0 of this? It is not so simple. So there is a standard procedure for that. First, find the factors of the constant term. Please look at the last term, which is the constant term, which does not have any variable. That constant term is minus 5. So how do we proceed? This is the first step. Second step is, what are the factors of minus 5? Minus 5 has factor plus minus 1 and plus minus 5. This plus minus 1 means plus 1 or minus 1. This means plus 5 or minus 5. So these are the factors of this. So if this is the factors, they could be the potential zeros of the polynomial. Let us check x equal to 1 first. We need to determine 1 0. So let us try with x equal to 1. So p of x equal to 1, we substitute in this. X cube minus 3x square minus 9 is equal to 1 cube. We substitute x as 1 minus 3 into 1 square minus 9 into 1 minus 5. So 1 square is 1 minus 3 minus 9 minus 12 minus 5 minus 17 plus 1 is minus 16. So when we substitute x equal to 1, the polynomial is not becoming 0. So what does it mean? It means x equal to 1 is not the 0 of this polynomial. So we need to find the 0, at least one 0 of the polynomial, then only we can factorize. So x equal to 1, this was not successful. Let us try x equal to minus 1. P of x equal to minus 1 equal to this expression. Now we replace x by minus 1. Minus 1 cube minus 3 into minus 1 square minus 9 into minus 1 minus 5. So this will be minus 1 cube will be minus 1, minus 1 square will be 1. So minus 3 into 1 minus 3, minus 1 minus 3, which is minus 4, minus 5 is, and minus 4 is minus 9. Here this is plus 9, 9 minus 9 is 0. So what does it mean? It means that x equal to minus 1 is one of the 0 of this polynomial. That should be our aim. We need to determine at least one 0 of the polynomial. Then we can factorize it. So now we got x equal to minus 1 is the 0 of the polynomial. If x equal to minus 1 is the 0, then x plus 1 is a factor of polynomial. We have seen earlier, if x equal to minus a is the 0, then x plus a is the factor of polynomial. So we are writing this as factor. So we got one factor. Now it is somewhat easier. Now we factorize this. We write on the left hand side. We start with x plus 1. We simply write x plus 1 first because it is the factor. Now we start comparing on the LHS. We need x cube. So we write here x square. So x square into x cube we got. So x square into 1 is x square. But we require minus 3x square. But we are getting plus 1x square. So we write here again x plus 1. Now we write minus 4x. Why we write minus 4x? Because minus 4x square plus x square from this term we will get minus 3x square. But we are getting now minus 4x. Minus 4x into 1 is minus 4x. But we have a term minus 9x. So we again write x plus 1 and write minus 5. Because now minus 5x minus 4x will be minus 9x and minus 5 into 1 is minus 5. So we got this term. Now x plus 1 can be taken common. So what are the balance term? X square minus 4x minus 5. That's what we have written. X square minus 4x minus 5. And the x plus 1 is the common term. Now this is a quadratic polynomial. We can solve like splitting the middle term. So the coefficient of x square is 1 here. 1 into minus 5 is minus 5. So we have to split minus 4 such that we get the term minus 5. So how do we split? We split as 1x minus 5x. So 1 into minus 5 is minus 5 and their sum is minus 4. So we write it as x square plus x minus 5x minus 5. Please note we are splitting the middle term as x minus 5x. Other two terms are kept as it is. Into x plus 1 was the we obtained from the previous one. So again taking common here, x plus 1 will be common and x minus 1. This is the factorization of this quadratic polynomial. X plus 1 was the balance. So this is the factorization of the cubic polynomial. I will once more summarize. For factorizing a cubic polynomial, we need to find one 0 at least, so that we can write that 1 0 in this form. To get the first 0, we need to look at the factors of the constant term. The constant term is minus 5. So we have to look for factors plus minus 1 and plus minus 5. These are the only factors of 5. Then from that plus minus 1 and plus minus 5, we try to get at least one 0 of the polynomial. So we substitute 1 in this, minus 1 in this, and luckily we got at p equal to x equal to minus 1, we got as one of the zeros. So once we get the 0, we get the first factor. Then we can get the other two factors. Now the various identities we have seen in the first video, like now we have to use those identities in finding factorization of x square minus y square by 100. Immediately when this expression is there, you should remember the identity a square minus b square. A square minus b square is a plus b into a minus b. So what is a here? A is x here and b is y by 10. Because if b square will be y square by 100, this one. So once we get a and b, we can just substitute here as x plus y by 10 into x minus y by 10. So a plus b into a minus b is a square, which is x square, minus y by 10 into y by 10, which is minus y square by 100. Now we need to evaluate 99 power 3 using appropriate identity. So we can write 99 power 3 as 100 minus 1 power 3. 99 is 100 minus 1. Now this is of the form a minus b the whole cube. A minus b the whole cube is a cube minus b cube minus 3ab into a minus b. We just substitute here. A will be 100 and b is 1. So we write 99 power 3 is 100 cube. A is 100. B is 1. So 100 cube minus 1 cube minus 3 into 100 into 1. 3ab into a minus b, which is 100 minus 1. So what is 100 cube is 100 into 100 into 100, which is 10 power 6. 1 cube is 1. So minus 1 minus 300 into 99. So solving this 300 into 99 is 29700. Subtracting this from this, we get our final answer as 970299. So 99 cube is 970299. Friends, with this we conclude this particular video. I hope you like this video. Please give a thumbs up to this video and subscribe my channel so that in future the videos can be released to you in a quick manner. Thank you very much, friends.